In this session, you are going to learn Chapter 11, Network, Example and Protocols. Content of this video is what is protocols, what is TCP/IP model. Protocols. Network protocols is the usual procedures, rules, formal standards and policies comprised of formats which allows communication between more than one device which is connected to the network. As we know, network is a collection of computers, and internet means the collection of computers which are connected all over the world is coming under internet. While we are connecting these devices, we are connecting them just for share our datas, that is said to be communication. So while we are sharing the datas, there is some rules and procedures to be followed to pass the message from one device to another device. This network protocols have to do end-to-end procedure of secure on-time managed data. So the network protocol has two responsibilities. One is it is framing the rules and policies how the data should be transferred. Next one, it is giving the assurance of security and management of data in the network communication. So what is a protocol? Protocol is a set of instruction. What it is going to do? It is going to give the rules and regulations for what to how the data should be communicated between the devices. Is it clear, children? Now, types of protocols. As we know, protocols are rules and regulations. They are going to give some instructions. The types are network communication, network security, network management. So, the network communication protocols is the basic data communication protocol which consists of HTTP transfer protocol, then TCP/IP, transmission control protocol. These two protocols are the base for the communication. Next one is network security protocol. Then HTTPS, hypertext transfer protocol secure. Then secure file transfer protocol, secure socket layers. So these types of protocols take care of the security of data over the network communication. Then network management, Internet Control Message Protocol, ICMP, Simple Network Management Protocol, SNMP. These protocol governs the network and maintains the devices connected in the network. So what are the three types of protocols? Network communication protocols, network security protocol, network management protocols. Next, come to our ICP, TCP/IP, Transmission Control Protocol, Internet Protocol. TCP/IP is a set of protocols which governs communication among all computers on the internet. So this is the important protocol for the communication. Then this protocol tells how information should be packed, sent and received, as well as how to get to its destination. So if you are sending a mail from your system, this TCP/IP protocol will take care of it. It converts the data into packets and sent and received, and as well as how to get to its destination, means it will take care whether it reached the destination or not. Sometimes if we give a error, that means a wrong email address, then immediately we will receive. Have you noticed that? Failure in delivery. So this is a wrong email address. So this content is not delivered to this particular IP address. That means particular email address. This TCP/IP protocol will give a acknowledgement about it, or else it will say as message sent, message successfully sent. Have you noticed that while you are sending your email? Hereafter notice it. Next, the TCP working nature. TCP/IP is the combination of two protocols. What are they? TCP and IP. So transmission control protocol, another one is internet protocol. So this internet protocol is going to have It specifies the logistics of packets that are sent out over networks. It specifies the packets which have to go, where to go, how to go. So what is the working nature of Internet protocol? It will say which have to go, where to go, how to go. Okay, then what about the TCP? Transmission Control Protocol guarantee the trustworthy. So it will take care of the guaranteeness of transmission of data. So it checks if the data packet is not transmitted and submits it again. So our data is converted in our data is having many formats of conversion. One of the format is packet. While the data is traveling, this TCP is taking care whether it is transmitted or not. If it is not transmitted, it will submit again. Okay, so it's doing favor for us. Next, this TCP IP is having 4 layers for its communication. One is network access layer, another one is internet layer, another one is transport layer, next application layer. What are the layers? Network access, internet, transport, application. So this is the whole scenario of TCP IP. If you are very clear with this diagram, then you are easy to write your 5-mark question, even 3-mark questions also. Look here, network interface, then internet, then transport, then application. Okay, 4 types, 4 layers in TCP IP. Next one is the network interface is a hardware type. All the 3, internet, transport and application, are software type. What is the difference of hardware and software? Hardware means it's a physical component. What is a physical component? See the protocols. Ethernet token ring. Ethernet is an adapter cable. Have you seen, if you are having any network connection in your lab, in your computer lab, there will be a blue color wire. Even this Ethernet is going to be a 5-mark question in later chapter. We will learn completely, but have an idea, it's a cable wire which is connecting the devices. So the network interface is a physical component. That internet, transport, application, these layers are software, so we cannot see it through our eyes, but these will do its instructions properly. So what it is going to do means everything is under the control of the protocols. So the network interface is taken care by the Ethernet or the token ring or other layer protocols. This internet network interface is Ethernet. Internet layer is taken care by the IP, Internet Protocol, ARP, ICMP, Address Resolution Protocol, Internet Control Management Protocol. This we are going to see now itself. So have an idea, internet layer is having 4 types of protocols. Then transport layer is having 2 types. One is TCP, another one is UDP. Then application is having 5. As per, I am saying this for your exam point of view. Application layer is having 5. 1, 2, 3. There is HTTP, FTP, Telnet, SMTP, DMS, Domain Management System. So this is the scenario of TCP IP. Now the data given here is first with the application. Application is having the user data, then the data is converted to segments in the transport layer, then the segments are converted into packets in the internet layer, then the packets are converted into bits and frames in the network interface. We can have in a reverse also. First network interface is having the data in bits and frames, then it is converted to packets, then it is converted to segments, then it is converted to its original data. It depends upon the receiver or the sender. But the thing is, the content is as a data in the application, as a segment in the transport layer, as a packet in the internet layer, as bits and frames in the network interface layer. Next, you can analyze now. User data. User data means, imagine that you are typing something in the browser, that is the user data, or the mail is the user data. This is the application layer, it is having the user data. Then this application layer is given moved to the transport layer, transmission control protocol. It will convert the user data into segments. Then the transport layer is given to the internet layer, internet protocol. It will convert the segments to packets. Okay, then the packets are given to the physical layer of Ethernet, that is our network interface layer. It will have bits and frames. As you know, bits and frames means bits are 1010, am I right? So this Ethernet is a physical layer. This cable will transmit the data in 1010 format. Is it clear? This is the communication process of TCP/IP. Now, each layer is explained in detail. Network interface layer, this is the physical layer. It is the bottommost level layer. It is comparable to that of open system, that is OS model. This is another 5-mark question. This will be explained in the next video. Just have an idea. This OS model is having 7 layers, but our TCP/IP is having 4 layers. So the network interface layer is compared with the physical and data link layers of OSI model. Then this TCP/IP protocol uses Ethernet and token ring protocols for the local area, LAN area network. If it is a WAN area, wide area network, it is using X.25 and frame relay. And it is assumed to be an unreliable layer. That means it is not guaranteed that this network interface layer alone will transmit the data to the particular device. Next one is the internet layer. This internet layer is the place where the data is addressed packed. That means it is converted into segments. Now it is here as packets, not as segments. So interface layer is bits and frames, then network interface layer is having bits and frames, then the internet layer is having packets. That means the data is in the form of packets, and this is having how many protocols? 4 important protocols in its layer. This you learnt in that tabular column previously. This is IP, ARP, ICMP, IGMP. All the 4 is having its own working nature. What is that? IP means routable protocol, which uses IP addresses to deliver packets. So it delivers the packets. It is an unreliable protocol, that it's not guarantee or it will not give the acknowledgement of delivery. But ARP takes care of this because it resolves IP address. That means it is having a method to MAC, that is medium access control. Address is a hardware identification number. What does this number means? As it is a device, each device is having a IP number. So this ARP protocol will resolve the identification. This packet should be given to which device. It will take care of it and it will pass the packets to that particular device. Then internet control message protocol. What's its working nature is the network device used by network devices to send error message. For example, if you send an email address of wrong, if you send a message to your wrong email address, suddenly you will receive an error message, right? So this control is taken by internet control message protocol. A host or router might not be reached or request service is not presented, it will give an error message. Then group management protocol means it is a communication protocol used by host and routers to send multicast message, that means group messages, to multiple IP address. That means many number of devices a message is passed at a time, means it is taken care by internet group management protocol. So what are the four protocols of internet layer? What are the four protocols? IP, ARP, ICMP, IGMP. Good. Next, transport layer. This layer, here the packets are converted to segments and it is swapped between the host, and it is taken care by two protocols. One is TCP, another one is UDP. What is the working nature of TCP? TCP provides a reliable connection-oriented transmission between hosts. It ensures delivery of packets. That is the important point. Next, but user datagram protocol provides a connectionless, unreliable one-to-one or one-to-many. So if this protocol is taking the data, means it is not guarantee. It is not guarantee means it will not give the assurance of guarantee. It just pass the message, but the TCP will take care of and give the assurance. Then application layer. Application layer of the TCP IP model is similar to session presentation application layer of OS. I already told there is another model OSI. It is having 7 layers. Among the 7 layers, session, presentation and application, all the three are equal to the application layer of TCP IP. We will discuss this in the next video. Now, what are the protocols in this application layer? Are HTTP, FTP, Telnet, SMTP and DNS. HTTP, the core protocol of the World Wide Web. Have you ever noticed if you type a website in your browser, this HTTP protocol will take your request through the URL. Next, the same procedure can be done by FTP. It will receive files from the server. Next is Telnet. So each protocol is having its own working nature. Next, the Telnet is to connect to another computer on the internet. Then simple mail transfer protocol provide email services. Then domain name system, it's an important concept. It is also going to be discussed later chapter. Refer to other host computers by using names rather than numbers. Yes, it's very important because this www.google.com is a domain name. Actually, it is replacing a number. If we are asked to remember the number, we surely forget it. So this domain name system only helping us to remember the IP address of many devices by the name Google, Yahoo, like that. So we'll discuss this later chapter. So what are the protocols in the application layer? HTTP, FTP, Telnet, SMTP, DNS. So we'll have a recap. TCP IP, it is having 4 layers: application, transport, internet, network, interface. Then what is the working nature? If we give a request to the web server, that is data, it is taken care by the application layer as data. Next, the transport layer will take care of it. Now it is a segment. Next, internet layer, data to TCP, that is transport layer. Now the data is in the form of segment. From the transport layer, it is given to the internet layer. Now it is in the form of packets. From the internet, it is given to the network interface layer, that is the Ethernet. In the Ethernet, it is in the form of bits and frame. So as you know, bits are 1010. The data is converted to 1010 and it is passed to the Ethernet, to the particular client. This is the working nature of TCP IP communication process. Learn this concept very well. Thank you. Have a good day.